Let's take a look at how we can implement an invite system. Now, if you've ever looked up how to do it or just following what mainstream applications usually do, you'll find this solution, and that is using tokens. So let's see the process. So a user invites someone. The backend generates this special token, then it stores the token in the database, and then the backend sends an email with an invite link containing the generated token. Then the user opens the link, hits the backend verifies the token, and either the frontend prompts the user to join the group or the user is added automatically. Now, if the user does not exist, then they will be prompted to log in, and once they do, they usually get redirected with that token, and then the same process takes place. However, this is not the best solution, and the reason is because it adds complexity, especially when creating and managing the tokens, including the invalidation of them. Plus, you need to set up a cron job that periodically removes the expired tokens. But that's just inherent to using databases for this case. You'll have to do this either way. Now there's a second solution, and that is using Redis, which is an in-memory cache. Now you could use memcached or any other alternative, that's up to you. But for simplicity's sake, let's say we're going to be using Redis. Now with the same process, so the user invites someone. The backend generates a unique identifier. So for that, it could be invites and then the group ID. Then we store that identifier in Redis with an expiration date, so that will be handled by Redis automatically. Then the backend sends an email with an invite link just to the application, so it notifies the user, hey, you have been invited, but it doesn't send any token or anything like that. Then the user opens the application, the backend sends to the client the pending invites for that particular user, then the user is shown a list of all of the pending invites, and upon accepting an invite, the backend validates the invite with Redis. It makes sure that it exists. If the user does not join before the expiration date, then the invite is automatically removed from Redis. Now, as for the benefits, well, Redis is designed for high-speed operations on in-memory datasets. So performance-wise, for reading and writing, it will be great. Now, Redis is also great for temporary data, so data that is short-lived, like invitations. So it's also great for this, but unfortunately it has some cons, and that is synchronization complexity. What if a group is deleted? Now you need to go over Redis and remove the pending invites for that group. And it also is harder for retrieval, so it becomes hard to retrieve invitations based on other criteria. What if you want to search all of the pending invites for a particular group and for a particular user? That becomes harder. So with this, we have the third solution, which is store the invitations directly in the database. So same as all of them, user invites someone, the backend stores the invitee's email, the group ID, and an expiration date in the database. Then the backend sends an email with a notification that the user has been invited. Then the user opens the application, and a dialog or a notification is shown for that pending invite, and the user can either accept or reject the invite. If the user does not accept before the expiration date, the invite is automatically marked for deletion in the database. So let's take a look at the pros. So first of all, simplicity. It's very straightforward to implement. You also get a soft deletion, as the expiration time column is inherently also used to mark records for deletion, which simplifies the process of removing expired invitations. And aside from that, well, obviously efficient retrieval. So if you set up indexes and a compound primary key for the group ID and the invitee email, then retrieving specific invitations is fast and easy. But this obviously comes with the trade-off that you need to have a periodic cleanup. So for this, you can create a stored procedure like delete expired invites, and this is simply going to remove all invites that are expired, which is this one, so expires at. So in this case, if it is older than 7 days, then remove it. Now for this you would use a cron job that runs maybe every 12 hours, ideally at a time when the table is less active. Maybe the vast majority of your user base sends invites in the afternoon. So this is something you have to do if you go the database route. Although if your application only has 100 concurrent users, you might as well either run the procedure every month or not even at all. You'll know what to do when the time comes. Now let's take a look at this demo application that I created. Now this is a proof of concept. It is not an actual product, but it is great for you to see how everything works all the way from the front end to the back end. So if I come here and sign in with an account, so this account, as we can see, we have, well, the user, we have this bell, which opens up a dialog with all of the pending invites. And we also have this button, create group. So if I click on this button, as we can see, we can create a group. Now this group just has a title, so we can say this is a test. And if I create it, as we can see, we only have one user, which is the owner. So in this case, it is Wombat. And if I come here, since I am the owner, I can invite members and I can delete the group. So let's invite someone. So I'll come here and say prudence.negotium, and then if I click on invite, as we can see, it has been added as a pending invite, of course, because, well, the user hasn't accepted the invite yet. But the great thing with this approach is that the owner has total control of the invites. So we, as an owner, can remove a pending invite. So before testing that out, let's switch accounts. And if I come here to this one, now as you can see, we get this dialog immediately. So we have a pending invite. And in fact, if I close this dialog, we have this highlighted button. So what happens if I accept the invite? Well, by doing this, as we can see, we are now part of the group. So we now have permissions to see this group. And if I come here, as we can see, we have the two members. So Wombat and Prudence. Now what about declining one? So if I come here and say declining, create, and then let's invite impish.wombat, invite, and then if I switch accounts, come here to Wombat, as we can see, we have this pending invite and we're not part of the group. But if I change back to Prudence, and then let's say we want to remove this pending invite, as we can see, invite has been removed. And now if I switch back to Wombat, as we can see, there are no longer pending invites. And in fact, if I come here again to invite a member, as we can see, we now have this member. Now this proof of concept does not have the ability to remove a member, but that's very straightforward. So if you want, you can implement that your own. But what if I try inviting someone? So the same member that is added. Well, if we do this, we get an error. User is already a member. But this is all in the client side. So here we're just doing a simple check. But in the backend, this is also enforced. Now what about yourself? So impish.wombat, well, we get you cannot invite yourself. So everything is as robust as possible. So now let's take a look at the code to see how I managed to do this. So for this, in the database, I just have a users table. So I store name, email, image URL, and then we have the groups. So a user can have a lot of groups, and also a user can be a member. So this is for owned groups, and this is for groups where they are a member. Now this is all with Next.js, and I'm using TRPC for the backend communication. So if you want to see how you can have authentication in Next.js 14, especially with the app router, make sure to check out my other video. Anyway, here for the group, I just store the title. We have to-dos, which is not implemented for this case, but it is simply for demonstration purposes. We also have the pending invites. So this is where we store the invites in the group invite. So a group can have a lot of invites. Then we have the owner. So only one person can be the owner. That makes sense. And then we have the members. So a one-to-many. So a group can have a lot of group members. As for the group members themselves, I just store the user, so we have a foreign key on the user ID and also, well, the foreign key for the group ID. And here we have a compound key, so there can only be one group member per group. So user ID and group ID, as simple as that. Then we have the to-do, we can skip this is not relevant. And finally, we have the group invites table. Now here, we store the invitee email. So as you can see, we do not have a foreign key with a user. There's no relation. And that's because the user might not exist. So we do not add that relation. So this is agnostic. We just store the invitee email. If you were to tie this to a user via this foreign key relation, then if the user doesn't exist, you cannot invite them. Now this depends on your application. Of course, if the user needs to exist for some reason, well, you can skip this invitee email and just store the user relation. But since this would be for like a SaaS or something of the like, then it's crucial for that user experience to allow inviting anyone, regardless of whether they are a user or not. And then we do have the relation for the group, and then we have the expiration time. So this is the key. This is what tells us if the group invite is valid or not. And then we have the compound key. So there can only be one group invite where the invitee email is this one and the group ID is this one. So this is a really nice constraint. And then we set up some indexes. So we set up an index for invitee email. This is crucial because we're going to retrieve all of the group invites for a particular user. So we need this index for that query performance. And then we have an index for the group ID, because if we want to retrieve all of the pending invites for a particular group, we can ensure that it is going to be as optimized as possible. And again, this is for the case when you click here on invite members and then you get all of the pending invites. That's where we use this. And then we have the index for the expiration time. And again, this would be crucial for the cron job. So when you want to delete all of the invalid group invites, it's good to have this index. Now, the reason we do not have an index for an invitee email and a group ID is because this compound primary key already does that for us. So it would be totally unnecessary to add a compound index for this case, since it is already covered by this compound key. Now, if you're new to indexes, just because we have an index for pretty much everything doesn't mean you should add an index to every single column in your tables. In fact, it might not be the best, since you're now hindering the performance for writing to the database and even for deleting, as it needs to scan the table to know where it will be placed. So make sure to never add arbitrary indexes. Always benchmark your database, add a lot of rows, make it as realistic as possible, or just look at your production logs so you know where an index could benefit. Anyway, let's move on to the actual logic. So here under server, so remember you can find the repository under the description, we have all of the logic. So we have the routers, we have the auth router, so again you can check that video out if you want. And we have the router for the group invites. So we can ignore the to-dos router. So here if I come to the groups router, we just have a basic CRUD. So we have a create group, a delete group, and then get all groups. So for this is all pretty well structured. So we're using services and repositories for that separation of concern, which in turn makes your code more maintainable in the long run. So here, for example, for get all groups, we have the service, we pass in the session, and here we just invoke this method get groups by user ID, which comes from the groups repository. So if I come here, this is just an SQL query. I'm using Kisely as the database driver and query builder, which is completely type safe. So we say select from groups, then we do some joins, left join for the group members and the users, and then we also do an inner join for the owner, and then we do a union, so to get those groups where the user is not an owner, so where they are a member. And then we do some data transformation here to make sure that it is in the format that we want. for each group. So in this case, where we have the created ad, the ID, the title, then updated ad, and then the members, which is an array of all of these, and then the owner, which is a group member, but without the updated ad column. And then we just return that. So the result of this might look like this. So if I come here to the query, we have get all groups, and here we have data, which is an array, and then we have the owner. So this person, we have Wombat, which is the owner, and then for the members, we have Prudence. So this member right here. Now this is what the query returns, an array of multiple groups. Now as for the other methods, so here in this service, we have the create group and the delete group. We have this groups repository.create group, and all of this is simply going to create the group. So we return all of the information for the newly created group, and then we query for the owner, and then we return the same information as we're doing here. So we're returning this group, but in this case, we know there are no members, so just an empty array. And the reason I returned the newly created group is for that cache update, so that we can update the cache without actually performing another request. But well, this depends on your use case. If you have pagination, sorting, and whatnot, then you would just invalidate the whole query. This depends on your application. And then we have the service for the delete group. So this one, we invoke this method right here, which just says delete from, and then well, we check where the ID is equal to the group ID and the owner ID is equal to the session. So we're passing the owner ID, which is the context.session.id. That way we ensure that the person deleting this group is the owner of the group. And then we just return a boolean, true or false, if it was successfully deleted, and if not, we just throw an error here in the service. So this is the whole CRUD we have for the groups. But now what about the group invites? So if I come here, we have the router, and here we have a send group invite, then accept group invite. We have the decline. So when the user does not want to accept the group invite, that's for the invitee. Then we have the remove pending invite. So this is for the owner that wants to get rid of that invite they sent. So this is for when the owner opens up invite members and then they send an invite. So for example, an email, so a@gmail.com, and then invite, we just created that invite, but well, the owner can remove it if they want. So they can say remove. So this is the handler, this is the route for that mutation. Then we have get pending invites for user. So this is for the invitee. So when the user first opens the application, they get the pending invites here. So this is the handler for that. And then we have the other query for get pending invites for group. So when the owner sends an invite, so for example, a@gmail.com invite, and then you refresh, come here, as you can see, this is retrieved from this query. So let's now take a look at the actual methods. So let's start with send group invite. So we pass in the input. So the input is just the group ID and then the email for the invitee. And if I come here, we check that, well, the email that we sent is different from the session so that you cannot invite yourself. Then we check if the group exists. And if not, well, group not found, or you're not the owner of the group. Then we check if the member exists. So if they already exist, we just throw a bad request. And then we have the expiration time. So we're using Luxon, which is a great library for handling dates. As you can see, it has .now and then .plus, and then you can say days 7. So this is absolutely great. Then to UTC and to JavaScript date, and then we just invoke the add pending invite in the repository. So again, we're using the repository pattern to separate the data access layer. We're not exposing the data access layer within the service. That would be terrible. So here we just say insert into group invites. And here's the interesting part. We have an on conflict, and then say when there is a conflict on group ID and the invite email, so the invite already exists, then we just say do update set, and then we pass in the expiration time. That way, if the expiration has expired, but the user wants to send an invite and the cron job hasn't deleted this pending expired invite, they can just do it right away. This is just going to update it. So it is going to update the expiration time to the new one. So let's see this in action. If I come here to my database and then come here to, let me actually invite someone. So let's say we have a@gmail.com. If I come here to group invite, we have this one right here, and then we have the expiration time. So what happens if I move this in the past? So let's say January 9th, so a month ago, and then save this in the database. If I come back here, refresh, make sure this tail data is gone. As we can see, there are no pending invites, but it still exists. So this is for the case where the cron job hasn't done its job yet. Maybe it is scheduled to run in 12 hours, and so well, the pending invite is still there. So for that, we can still say @gmail.com, and then we click invite, and this is going to update the invite. And if I come here to the output, so here in the run, as we can see, we have the select, but we have the insert into group invites, and we pass in the values, and then on conflict, so on conflict for the group ID and the invite email, do update set, and then we pass in the new expiration time. So this is all being handled by SQL either way, making it much simpler. And actually, I had to refactor this because the on collision we had somewhere here the on conflict, where we say do update set, well, the problem is it is going to update it if it already exists. So it allows someone to abuse this. So they could invite over and over and over again the person, and that person is going to have an infinite pending invite. Of course, you could set up a rate limiter, but that's something we can avoid anyway. So for that, I had to change the logic a little bit. So instead, what we do is search for the group invite. If it doesn't exist, well, we just insert the invite, and well, we return 1, saying that we inserted one row. As simple as that. But in the case where it already exists, then that's where the logic for the expiration time happens. So we get the current time and then the existing expiration time. And all we do is check if the current time is less than or equal to the existing expiration time minus 2 days. This way, let's say it expires in 4 days, then the user tries to invite the user again, they cannot do that. But if 5 days have passed, so this condition right here, so if the expiration time is set for 7 days and 5 days have passed, then the user can invite the person again. Otherwise, they get an error saying user already has a pending invite for this group. So this is a way to limit someone from abusing this. So in my case, as I just said, the expiration time for the invites are 7 days, but you could use 14 days and adjust this accordingly to your needs. And well, for the case where this is not true, so the expiration time for this invite has already exceeded this, then we just update the row. So we just get the group ID, invite email, and then we just set the expiration time to the new one. As simple as that. That way we avoid deleting these and then inserting another one. We can avoid this double trip to the database with just an update statement. And then again, here we just catch the errors. But if you want, you may as well just get rid of this condition and just check against the expiration time. Whatever floats your boat. This depends entirely on the user experience you want to give. So yeah, this is all of the logic. Again, we just invoke group invites repository, add a pending invite, we pass in the information from the service, and that's pretty much it. So then we have the accept group invite. So when the invitee wants to join a group, well, for that, we first of all check if the member exists. So we pass in the session that email, and if they are already a part of the group, so they are a member, then we just throw an error saying you are already a member of this group. Which in fact, now that I think about it, I believe we should move this up. So this is the first condition. So we check if the pending invite exists. That way we avoid looking up the group's repository and instead look for the group's invite, so the table. So that's the first thing we check. So we check if the pending invite exists. If so, we move on to this logic right here. That way no one can really abuse this. As well, you have to first create the pending invite, but you cannot do that if you are already a member. So we can switch this up. I think this is better handling of the conditions. So again, we check pending invite exists and if the member exists. So if either of these two are true, we just throw the corresponding errors. And then all we do is say add member to group, and then we delete the pending invite. Now, before moving on, I just noticed that this is not the best collocation of the methods. And that's because, well, the group invites repository should actually be the one managing the adding a member to a group, right? That makes sense because, well, you can only add a member to a group via an invite when the user accepts the invite. So for that, I actually need to refactor this. So we move this to the group's invites repository, but not only that, we also use a transaction. So we know that, well, if this fails or this fails for some reason, well, this is reverted and we do not add the member. That way we do not get this stale pending invite. Okay, so I just refactored this and, well, I added this method, add member to group and remove pending invite. And if I come here, all I do is say transaction, and then we get the transaction, and then we say select from groups. We search for the group. So if the group doesn't exist, well, we throw an error. Then we insert into group members and we pass in the group ID and the user ID to add. So this is for this session. So here we have session.id, and then we delete from group invites where the group ID is the one that we're looking up for, and the invitee email is equal to the session email, and we execute this. So if any of these fails, then it is going to revert it back. So we preserve the correct state in the database, and this is crucial. So we can test it out really fast. So we can have this and then invite Wombat, and then if I change account back into Wombat and then accept it, as we can see, we now have this group. So now Wombat is a member of this group. So with this, we have the accept group invite. Now what about declining a group invite? Well, this is pretty rudimentary. All we do is delete from group invites the one where the invitee email is equal to the session, basically. So this is again for declining a group invite where you are the one that was invited. And then we have the remove pending invite, and this is for the owner so that the owner can invite someone, so a@gmail.com, and then they can remove this pending invite. So this, all we do is check if the group exists. So for this, if I come here to this method, we simply search for the group where the owner ID is the one that we passed in. That way we can check for privileges. If the person that is trying to do this is a member or in fact doesn't even exist for this group as an owner or a member, then well, group not found, or you are not the owner of the group. And then we delete the pending invite. So we use this same method here, but instead of passing this session, because well, this is for the person declining the invite they got, we just pass in the invitee email, which comes from the input from the router. So here, remove, and we can pass in the invitee email. And then we have get pending invites for user. So this is for this dialog. So we can render the list of pending invites that comes from this method, which just invokes the repository for get pending invites for user. And here we just check that the expiration time is greater than the current time. So if it's less than, then that means that it has expired, as simple as that. And then we get all of them, so we get the group IDs. Well, if it's 0, then there are no invites, so we return an empty array. Otherwise, what we do is get the groups where the ID in group IDs. So we get all of the groups for the pending invites. And this is so that we can show additional information in the invite. So if I come here, delete this, then test, and if I come here and invite Prudence, and then if I change my account, and then come here to Prudence, as we can see, we have the name of this, but we also send the information for the owner so that we could display that in the front end, which we're not doing, but it's good to have, so the user knows who invited them. So we have this, we get it, and then we get the user by ID, so we get each of the owners, and we just set the owner to this one, and then we just pass in each invite. So each invite looks like this. We have the group ID, we have the title of the group, and then we have the owner. Nothing crazy. And then after this, we have get pending invites for group. So this is for the owner, where they can come here and they get the pending invites. So here, all we do is say check group existence. So we pass in the group ID and the session ID, which corresponds to the owner of the group. And well, we do the same check as in the other service method, where group not found or you are not the owner of the group. And then we return get pending invites for group, which all it does is do the same. So expiration time is greater than the current time, and then return invites.map, and then we return from each invite the invitee email. So again, we can show all of these ones, so a@gmail.com, and there is no more information than this, because again, we're not using a foreign key to the user table. We're keeping things as general as possible, which is only via the invitee email. That way a user can invite someone that doesn't even exist. Now, as for the cron job itself, well, it's pretty basic. You'd have like a delete expired invites, then you get the current time, and all you do is say delete from group invites, where expiration time is less than the current time, and you would of course add a limit to avoid locking up the database, and then just an execute, and well, you would set up the cron expression. You could use a cron library for that. So for example, node cron, so you could say cron expression every 12 hours, you pass in the expression, and then you schedule it so that it is simply going to delete the expired invites. And that's pretty much it. Now, this depends entirely on the environment you're running in. In this case, I'm using Next.js, and most providers will run your application in serverless, meaning that you cannot use this. You cannot have a long running process. As well, it is a serverless function. So for that, you'd have to devise your own solution. Or if you're using Vercel, they have cron jobs, if I'm not mistaken. So here, I believe, yeah, you can create a Vercel.json, and then you can say the path. So you have to map this over to the API. So you'd have to create a route for that in your API directory, and then you can schedule this. And well, it is going to automatically hit up your API endpoint and run whatever function you define there. So that's one way to do this. Now, if you're interested in the front-end development, I'm not going to cover it in its entirety here, but it's pretty basic. So here in the main page, so the root page, we have this create group model, and we have the button that is going to open up the model. So this one right here, where we have this create group button, it is going to open this up, and then we have the list for the groups, these ones. So if I come here to create group model, we have use form from React Hook form, and we pass in the resolver, which comes from the API directory that we have there with the SOT schemas. And then we have create group, and once we create one, we invalidate the query, so it is going to perform it once again, or well, again, you could use the cache. So you can get the result from this. So we get access to data, and that is going to be of type group. So you can just set data and replace or update the cached info for this query. And the handle submit, we use React Hot Toast, which is great because it gives you this great utility for promises. So you can say toast.promise, you pass in a promise, and then once it's loading, it is going to trigger this message. On success, it is a function, so you can return either a string like this right away, like you're doing here, or you can invoke this function, get even the data from this mutation. So as we can see, this should be of type group, as we can see here. So if you need to do some validation here, you can do that as well. But here, well, I just reset the form, close the modal, and on error, I just have this utility function that is going to check the type of error. If it's of instance error, then just error.message. If it's from TRPC, then just say the message. We can pass in a custom message, or well, the message that comes from the server. Otherwise, it is an unknown error. And then we render this form. And as well for the groups themselves, which this should actually be groups query, not to-dos query. Here, we just render these group cards. And if I come here, we use the session. So again, if you're interested in the authentication part, check out my other video. We check if the user is the owner. So we compare that against the group.owner. We render the avatars. So these ones with a tooltip. So we can show this information, and then we render a badge with the creation date. But we also render this drop-down menu if the user is the owner. So it's owner and owner actions menu. And this is just going to render this drop-down menu. And we have the delete and the invite members. For the invite members, if I come here to invite members modal, so again, this one where we can invite people or remove pending invites, we have this query. So pending invites query, we call get pending invites for group, we pass in the group ID, and then we use that to render the pending invites. So here, if I scroll down, we have pending invites .data.map, and we render the pending invites. And as for the group members themselves, we do the same here, and we have the footer for the dialog, and then the form, which allows you to invite a member with this button. As for the invalidation of the cache, we have here, so when we send an invite, we just invalidate this query right here. So we add that info here. So if I say b@gmail.com, click invite, it is going to invalidate this query right here, which again pertains to this one. So invalidate, and we pass in the same group ID. So it is going to perform the query again. And as for removing a pending invite, well, it's here where we render each pending invitee. And here we just have this mutation, and on success, we just replace the cache data. So we target again, get pending invites for group, and we filter out that invite email. So we remove it from here. And this is when we remove it. So if I click on remove, it is going to optimistically, well, not optimistically, but it is going to replace the cache instead of invalidating the query and performing an extra request to the server. And well, we just render the button and the span. And as for the notifications, if you're interested in that, here we have the header, and in the header, we have the logout, so we can change the user, so the session, but we also have this group invites model. So this one right here. So if I click on it, we have this open, and this is important because we need to control it. So if we have a pending invite and we refresh, as we can see, we get the modal open. And to do that, all we do is use a use effect. Then we check the pending invites query.data. So the pending invites here, in this case, it's this one. And then for this case, we just say if there are pending invites, so the length is greater than 0, then we set it open programmatically. Otherwise, well, it's going to be hidden either way. And then we get the pending invites. We have this conditional style. So if there are pending invites, we get this highlighted button. And then here, as for the dialog, well, we just render the pending invites. And for each one, we render a pending invite row. And here we have the accept invite and decline invite mutations. Again, we do the cache updates, make sure everything is as synchronized as possible for that great user experience. And then we render the two buttons for accepting and declining the invites. So these two. And that's pretty much it. This is the whole application. Again, this is a proof of concept. This is not an actual application, but you can use this if you want to implement your own system for invites. You can get inspiration from this, even improve it if you can, optimize some things or add some more functionality. This is now all on you. Now, if you're wondering about sending an actual email, well, for that, you could come here under API, then Common. So this is all of the shared utility code for all of the routers, and you would create a service for the email. So email.service.ts, and then here you could have a class, or you could have separate functions, whatever floats your boat, which simply wraps your service provider. So you could use Twilio or whichever you prefer, and then you can come here to the group invites.service, and then when you send a group invite, once all of this is done, so once this has been executed successfully, you can say email service dot send group invite email, or well, this is too specific, so you'd say send email, and then here you'd pass the two, so input dot email, then the subject, then the text, and then you could leave a link to the application. So this depends on you, of course. So this now wraps the video. Again, you can find the repository in the description. If you want to see more content like this, make sure to like the video and subscribe. I'll see you in the next one.